So welcome back to Engineering Economy course, and we were talking about Chapter 5, evaluating a single project, whether to accept a single project or not. And in our previous lectures, as I told, we learned about present, future, and annual worth methods, and we started learning the internal rate of return. And in today's lecture, we will continue our discussion on internal rate of return. So let's get started. So the internal rate of return, if we remember or memorize our previous lecture, internal rate of return is the interest rate. Okay, interest rate that makes the present worth of the revenues equal to the present worth of the expenses. So this RK represents the present worth of all the revenues, all cash inflows at time K, and we are finding its present worth. And these expenses represent the present worth of all the expenses occurring at time K multiplied by the corresponding factor. Okay, and when we find this, of course, we solve this equation for this interest rate, I prime. It represents IRR, the internal rate of return. If IRR is greater than or equal to our minimum attractive rate of return, MAR, we accept the project. Otherwise, we reject it. And in order to solve this equation, we simply take the difference, revenues minus expenses, and make it equal to 0 and solve for the IRR in this equation. And if we look at the present worth of a cash flow of a project using different interest rates, so this axis shows the interest rate, and using different interest rates may yield different present worths. Okay, so for example, if you use a smaller interest rate, then the present worth can be a higher value, a positive value. If you increase the interest rate, it may reduce, and after some time maybe the present worth becomes negative. Of course, this is the rate of return of the project, and we don't know what it is. We are going to solve for it. And the definition of IRR says that it is the interest rate that makes the present worth of the project cash flows equal to 0. So in fact, in this graph, we try to find the value of the interest which makes this present worth equal to 0 that intersects this horizontal axis. Okay, so this I prime is the IRR, or the internal rate of return. Okay, an example to understand the concept better. It says that a bank lends 10,000. Okay, let me sketch the cash flow. A bank lends $10,000. So this is the $10,000 that has been lended at time 0, and receives annual repayment of this much over 3 years. So we have 1, 2, 3 years, and at each year I'm receiving these payments, and the payment amount is this much. Okay, so for 3 years, 1, 2, 3 years. If this is the case, then what is the earning rate, the return rate for this bank? Of course, banks gives or lends money in order to earn, in order to make profit. Okay, so then this is if you look at from the perspective of a bank, this is an investment for a bank. It makes some initial investment and then it earns some revenue. And at the end, the bank wants some earnings, some return. And if you look at this, so what we want, this is the expense, present value of expense. So what was the definition of the rate of return? It is the present worth of revenues. And I can find the present worth of these revenues by using this formula P given A, the interest rate or the rate of return. And for 3 years, this is the present worth of the revenues minus the present worth of expenses, which is 10,000, which is already at present time. And we will make this equal to 0. And we are going to solve this equation for this I prime. And when you solve it, you will see that the interest rate that makes this equation equal to 0 is 10%. So in this case, we would say that the bank is earning a return of 10%. Okay, this is the rate of return for the bank. If we have a look at in more detail on what's going on actually in this investment, we can do this table. We can prepare this table. So at year 0, the bank lends this money, $10,000. Okay, so in this year, there is no, payment received, and there is no return because it is just the beginning of the year. So at the end of the year, the unpaid balance is 10,000. So this is from the beginning of the year to the end of the year. We are considering this in row 1. Then in year 1, what happens? The unpaid balance is 10,000. Then the bank earns 10% interest for this unpaid balance because it remained in the bank, it remained in the borrower for 1 year. So it started or it is now, it can earn this interest, and it is 10% of the original amount, which is $1,000. Then at the end of this year, the borrower pays $4,021 back. So in total, the amount that I borrowed was 10,000 plus the interest rate is 1,000. So in total now there are 11,000. It's 11,000. The total amount that the borrower owes to the bank is now 11,000, and it pays this amount back. So the remaining balance will be 11,000 minus this much. It will be 6,979. Okay. So then what happens? In the next year, at the beginning of the next year, this amount will be the amount that is borrowed. This is the balance. And then interest rate is 10% is applied to this amount. So it means that the interest rate is this much that I am going to pay. So the total amount that I owe to the bank at this year is now the summation of these two values. And I am paying again an equal amount of this much. So in total, my debt to the bank is this unpaid balance plus the interest minus what I paid, so which is this value, the remaining amount. So what happens in year 3? At the end of this, at the beginning of this year 3, the unpaid balance is this much. And I need to pay a 10% interest for this value, which is this much. So in total, I owe to the bank this summation. And what I am paying is this value. So if I subtract this value from this summation, the balance at the end of year 3 is 0. It means that I paid all this debt. This is how we can see what is going on at each year. This is the interest that I am paying each year. This is the total amount that I pay to the bank each year. And if you subtract this 1,000 interest from this one, the $3,021 is what I am paying from the original amount, the capital amount. So this is interest, this is capital payment, and in total I am paying this much, and my debt reduces to this much. Okay? And simply with this calculation, we see that the bank earns 10% internal rate of return with this lending $10,000 for 3 years. This graph shows a typical investment balance diagram for a project cash flow, and assume that this cash flow is something like this. At the beginning, we make some investment, and then at the end of each year, we have some revenues and we have some expenses. We have some revenues and expenses, and it continues till to the project lifetime. We have revenues and expenses. Of course, these revenues and expenses can be different from each other at each year, or it can be similar. And also, we expect that these revenues should be greater than to be these expenses. Otherwise, there is no way to recover your initial investment. Okay? If the total expenses, I mean the present worth of these total expenses is larger than the present worth of these total revenues, then there is no way that you can make profit. So, and what happens when we consider the time value of money is, this is the initial investment amount. Then in one period of time, this initial investment, it can be 1 year, 1 month, whatever the period of payments or earnings. Let's say this is years for this example. In 1 year of time, I need to pay an interest to this initial investment. So that amount becomes P times 1 plus I prime. This is the future value of this initial investment. And then I am earning some revenues and I have some expenses. So R1 minus E1 is the net earning for me at the end of year 1. So this was the initial amount that I borrowed or initial investment plus its interest. And I am earning R1 minus E1, so my debt reduces to this much. In second year, this amount again increases due to the time value of money for another year. And then from this value, again, I am earning this net R2 minus E2 amount, so my debt reduces to this much. Again, because of interest, it increases, but then I earn this much. So at the end of the lifetime of the project, if I use the internal rate of return of this project, the net balance will be equal to 0 at the end of the project lifetime. So this interest rate, I prime, is the value that makes the final balance of the project cash flow to be equal to 0. Okay? This is the idea of internal rate of return. If you are using a different rate of return than this I prime, then the internal rate of return, either this final balance will be something positive or it will be something negative. Only the internal rate of return will make it equal to 0 at the end of the project lifetime. Let's consider this example. It says that a capital investment of 10,000 can be made in a project that will produce a uniform annual revenue of 5,310 for 5 years. Okay, so the first thing is to sketch the cash flow diagram. So we have an initial investment amount of $10,000, and the lifetime it's said to be 5 years. And it says that an uniform annual revenue at each year is equal to $5,310. And it says that annual expenses, let me sketch with a different color. At each year, I have also some expenses, and these expenses are $3,000. Okay? It says that the company is willing to accept any project that will earn at least 10%. So what is this 10%? It is MAR of this company. Okay? The company will accept the project if it earns more than this value. Otherwise, it will reject. And it says that determine whether it's acceptable by using IRR method. Of course, in order to evaluate this project, you could use the present worth method. So collect every cash flow to present time using this 10%. And if it is greater than 0, you accept it. Otherwise, you reject it. You can use it. But in this question, we are asked to use the rate of return method. And in order to do this rate of return, what shall we do? Look, at each period, when you compare the cash flows, you have an earning of 5,310 and you have an expense of 3,000. So you can only concentrate on the net amount. And the net amount is this one, revenue minus expense, which is $2,310. Okay, this is the net amount. And the cash flow diagram actually looks like something like this. Okay, we have this initial investment of 10,000 and we have annual net earnings of 2,310. And what is the interest rate that makes the expenses equal to revenues? And simply you can use this formula, transform these annual payments to present time for 5 years and subtract the initial investment from this one and make it equal to 0. And we need to solve for this I prime here. Now the question is how we can solve for this I prime. You can use different methods. You can, instead of using this factor, you can enter the formula for this factor P given A and try to find it, try to solve that formula for I prime. But again, it is not very easy because this I prime formula for P given A includes to the power of 5 of this I prime and etc. What you can do is you can try different values. For example, if look at the table, when I prime is equal to 4, this factor P given A is 3.6299. Then use this in this equation and find the value to see if it is equal to 0 or not, and to see if it is greater than 0 or not. And then you try another value, you try 5, 6, 7, and etc. Different values, and you will see that, for example, this is greater than 0, this is greater than 0, this is greater than 0, but at some point it will be less than 0. So there will be a critical point where this present word changes from positive to negative. Okay? Then what you can do is, you can assume that, remember the graph of present word. So it starts from positive value and then it turns to negative. So at some point it becomes 0. And that 0 should be in between these two interest rates. Then you can use the interpolation, linear interpolation, to find an estimated value. I will show it in a minute. Okay, so now let me show you the solution. Of course, we have this market value, which we need to include it in the 5th period, at the end of the 5th period, and we need to convert that one to the present time using this as well. And what we try to do is we try to solve this equation, make it equal to 0, try to find the interest rate that makes this equal to 0. And as I told you, we can use trial and error method. And if you use, for example, 5% interest rate in this equation, it seems that the present word is positive and it is this much. Of course, if you have time, if you have computational power, you can do like this. Okay, 5%, 6%, 7%, 8%, try every one of them. But if you want to find it quickly, if you don't have that much time, then because trying these one by one may take a lot of time until you find where this present word switched from positive to negative. Instead of moving one by one, you can move 5 or 10 units at a time. So try 5% and then try 15%. And when you use 15% in the equation, we see that the present word is negative now. So in between 5 and 15, this present word switch from positive to negative. Look at this graph. This blue denotes the actual present word. And as you can see, for 5% it is positive, and for 15% it is negative. And in between these, it should be 0. But the thing is, it has a nonlinear behavior. It is not a line. Okay, it has a nonlinear behavior. But what we can do is, during this, in between these intervals 5 and 15, we can assume it to be a line. As I told you, there are different methods. You can use Excel as well, yes. You can use some numerical calculators, numerical methods, MATLAB, to find this value. Okay, but one of these methods is this. Of course, for example, if it is asked in an exam, since you will not be able to use Excel, you will be using this linear interpolation. That is why it's important to learn how we solve for this I prime. Okay, so again, what we do, we assume that in between these 2 points, although it is not linear, we will assume it to be linear, like this black line connecting these 2 points. Now, if you look at here, what we try to find is, we try to find this point. What is this value over here? The interest rate. And we can just use the triangle, similarity of the triangles, this small one and this larger one, okay, and find the interest rate here. According to that one, the line, let me clean up some space here. Okay, this line BA, which is this one, divided by BC for the larger triangle should be equal to the line DA for the smaller triangle divided by DE. Okay? And then from here we just plug in the values. What is the length of BA? What is the length of this? It is 0.15 here minus 0.05 here. So this is line BA divided by line BC, this one. So this value over here is 1568, and this value over here minus, of course, pay attention to the sign, this much. Okay, and this should be equal to line DA, this one that I don't know. Okay, so this value that I don't know, it is I prime minus 0.05. So this length will be that much, divided by DE. DE is this value, which is 1568. And using this equation, we can solve for I prime. And of course, this is not exactly correct. There is a mistake over here. There is an error. What is that error? Here, as you can see, the original one is nonlinear and it intersects the 0 at this point. But when we assume it to be linear, we will find this point. So this difference will be the error that we are making, okay, in this method. But of course, in this method, we used 5% and 15% as the two values. But instead of 5%, if I use, for example, 8%, it will have this value, and 12% here, it will be this value. And in between these, if I use this linear interpolation, so this line over here, as you can see, my error was smaller. The previous error was this much, new error is this much. And if you use even closer values, the error will be smaller and smaller. But of course, it depends on how much time you have. So in order to find this point where the present word switches from positive to negative, you need to make trials. And if you do too many trials, it will take too much time. If you want to find it quickly, you may jump from 5 to 15 to 25, and as soon as it switches the sign, then you can assume these two values. Okay, and when we solve this I prime using this equation that I sketched, we see that the internal rate of return is 10.5%. But look, in the question, the MAR is given as 10% to us. So what is our decision? Since the rate of return of the project is greater than MAR, we would accept the project. Our decision is this. But of course, they are very close to each other. I mean, the internal rate of return and the MAR are very close to each other, 10.5%, 10%. And maybe this is because the error that we did, remember, we did an error. Instead of having this nonlinear, we assume it to be line, and the actual value was this much, but we found this much. Maybe the correct value is less. And actually in this one, when you find the optimal one, I mean the correct value, it is 10%. The IRR is exactly 10%, and it is exactly equal to the MAR. When it is exactly equal to the MAR, of course, you are not rejecting, you are indifferent. Even if you accept or reject, it doesn't make a change for you. But the thing is, you cannot say that definitely accept the project because it is not greater than MAR. So this error, if the internal rate of return after you find after this procedure is very closer to the MAR, then it is better to make a better analysis to find an more accurate value. But if instead this IRR that we found was 13% and the one MAR was 10%, since this difference is too much, even if we made this 0.5 error, we are still better than the MAR. Okay, so this is how we can solve such an example. Of course, we can use, as I told you, other methods. Instead of solving like this using a linear interpolation, we can use a numerical method. And simply, instead of writing the equation with factors, we plug in their formulas. And using these formulas in our calculation, this expense making equal to the present worth of the revenues. So this is P given A and this is P given F formula. And now we need to solve this equation for I. And as you can see, it is still not that easy to solve this equation because we have 1 plus I to the power 5 and etc. in all numerator, denominator. We need to find the interest rate which makes this equation equal to 0. And how you can do it, again, you can use some computer software or some numerical methods. In Excel, you can use the goal-seek property. There is such a function in Excel. And when you do this, solve this using a numerical method, for example, you can find this result, 0.099. And simply this is approximately 10%. At the end of this numerical method, we can find it to be 10%. And since it is equal to the MAR, you are indifferent whether to accept this project or reject it. Another example to demonstrate how we use this MAR and how we calculate it, IRR, sorry. It says that a piece of new equipment has been proposed by engineers to increase the productivity of a certain manual welding operation. Okay. The investment cost is 25,000. Again, in these projects, we usually have similar cash flows. We initially have an initial investment, and in this project, it says that the initial investment amount is 25,000. And it says that the equipment will have a market value of 5,000 at the end of its expected life of 5 years. So this is 5 years and it has a market value of 5,000 at the end. And it says that because of the productivity increase, we will earn $8,000 per year extra after submitting the costs. So this is the net amount that we are earning, $8,000. It says that evaluate this project using the IRR. In this example, the MAR is given as 20%. Again, I'm repeating, if you like, you can use the present worth, future worth, or annual worth method also to evaluate this project. For example, if you want to use the annual worth, these 8,000 are already annual amounts. I need to convert this 25,000 to annual and this salvage value again to annual, and we call that this is the capital recovery, right? The capital recovery factor. And when we find it, if the annual worth, including this 8,000 as well, if the annual worth is greater than 0, of course, while converting them, we use the MAR as the interest rate. If it is greater than 0, we accept it. Otherwise, we reject it. But here, we are going to use the IRR method, the rate of return method. And in order to use the rate of return method, again, we will collect everything in the present time. So this 8,000 P given A, I %, we don't know it yet, and the lifetime is 5, plus this 5,000 salvage value, P given F, I %, and 5, and subtract the expenses, which is $25,000, and we want this value to be equal to 0. And now we need to solve for this unknown interest value. Okay, again, we can use a similar trial and error procedure together with linear interpolation to find this I prime value. And when you do it, I'm going to show it in a minute, we find that the IRR value to be 22%. Okay, 22%. And when you compare this with MAR, which is 20%, okay, so since it is larger than MAR, we say that accept the project. Of course, if you evaluate this I prime, because this may include some error, if you evaluate and find a more accurate value, the correct value is 21.577, and as you can see, it's still larger than MAR. So the decision does not change according to the initial IRR value that you find after this procedure, or with a more accurate value, the decision does not change. And of course, how do we find this IRR from this equation? Let me show it. So you use different values. You can start from 0 interest rate, and we find that the present worth to be 20. Okay, it is greater than 0. Then you use another value, 10%, and you see it is greater than 0. 20% greater than 0. 25% less than 0. So you don't need to continue and check the others. This is the critical point. The present worth switch from positive to negative. So if you look at the graph, this one is the actual present worth. When you try 0.20, you find this value. When you try 25% interest rate, you find this value. And it means that in between these, the interest rate or the present worth should intersect the horizontal axis, so its value will be 0. Now, what is that value? We know that it's in between 20% and 25%, but what actual value is it? Again, we will assume that this graph is a line in between these 2 points. Actually, it is not, but we will assume it to be a line. And using this triangle again, we will try to find this I prime value, this small triangle and this large triangle. We will use the same idea. So let me show it. This is the part, this is the larger part where this present worth crossed this horizontal axis, intersect that one. So this is point A, which corresponds to 20% interest rate. and this is point B, which corresponds to 25% interest rate. So simply what we will do, this in this larger triangle, this side divided by this side, so 25% minus 20 minus 0.2, this one, divided by this one, which is the difference of the present worth values, should be equal to, in the smaller triangle, this side divided by this side. And this side over here is I prime minus 0.2, like this. And this one over here is this value minus 0, this one. And from here we find this I prime to be 21.7%, and since this is larger than MAR, which is 20%, we accept. You can say that, why are we trying this hard? Because in present worth and future worth methods, simply we don't need to do these calculations. We just find the present worth using the MAR, M-A-R-R, and we would see if it is larger than 0 or not easily. But the thing is, in our previous lecture, I told you that, what does this tells you? Present worth being $10,000, okay, for a given MAR value 20%. If the present worth is 10,000, what information do you have? You know that this is greater than 0. You can say that, okay, accept the project because we are earning more than MAR. But actually, what is your actual earning rate? What was the total investment that you are doing? And with respect to that total investment, what is the percentage that you are earning? But if I tell you that the IRR for this project is, let's say, 25%, it gives you a better idea. It says that if you invest 100, you will get 125. If you invest 1,000, you will get 1,250. Exactly 25% more than the initial investment that you. But here, in the present world, we don't know what is the initial investment amount. You are earning 10,000 by, for example, investing 1,000 or by investing 100,000. Okay, so this is why the IRR method can be more preferable, and even if we know the present worth, even if we make this our decision with respect to the present worth, knowing this additional information with the IRR method is more beneficial, and it's used a lot.